Hey everybody, welcome to the next edition of Miss Blue's Calc Clues. So I wanted to take some time to create a video for you about the free response question from the AP exam back in the year 2000. It was a great exam because it just so happens to be the one that I got to take when I took AP Calculus AB. So anyway, in this particular problem, they have given us information about two runners, runner A and runner B, and they run on a straight racetrack for 10 seconds. So the time starts at 0 and ends at 10. The graph above, which consists of two line segments, and they gave you the graph, shows the velocity given to us in meters per second of runner A, and then the velocity in meters per second for runner B is given by the function v of t, which is 24t over 2t plus 3. So the first question asks us to find the velocity of runner A and the velocity of runner B at a time of 2 seconds and to indicate the unit of measure. So this was simply a matter of making sure that we are reading and interpreting the graphs and the functions that we were given correctly. So if you look at the graph for runner A, we'll notice that it is a little bit difficult to decipher from the graph what the velocity is at 2 seconds. But they have given us a few really important points on the graph that could help us. So on the interval from a time of 0 to a time of 3, the velocity function behaves like a line with a positive slope. And then from 3 to 10, it behaves like a line with a horizontal line that has a slope of 0. So if I want to know what the velocity for runner A is at a time of 2, I need to create an equation for that line segment that spans from a time of 0 to a time of 3. So when I do that, I notice that the y-intercept of that line is 0, and it has a slope of 10 thirds. So the equation would be v of t equals 10 thirds t. So if I want to, and this of course is only between the times of 0 and 3. So v of t then would be 10 thirds times 2, which is 20 thirds. Again, my units are meters per second, so I want to make sure that I include those. Each open-ended on each free response on an AP exam is worth 9 points. And so this answer here of 20 over 3 meters per second earned you one of the 9 points, so you're off to a good start. Now, runner B, it's even simpler to find his or her velocity at a time of 2 because we are simply going to plug 2 into the given velocity formula. And when we do that, we get a velocity of 48/7 meters per second. You can leave it as that improper fraction. In fact, it's probably preferable that you do so that you're not wasting time or getting lost in any unnecessary calculations. All right, so that's part A. So now let's think about part B. Part B of this particular problem asks us to find the acceleration of runner A and the acceleration of runner B at a time of 2 as well. So for this particular part, we need to go back to our most basic fundamental relationships. And that is that the acceleration function is the derivative of the velocity. So if we want to find the acceleration of runner A at 2, we want to find the derivative of the velocity evaluated at 2. Now, the derivative of a function is the function slope. So the slope of the velocity function at a time of 2 is 10 thirds. And my units for my acceleration are going to be meters per second squared. We just earned ourselves another point, my friends. We're a third of the way there. So now let's look at runner B. To find the the acceleration rather, of runner B, we are looking for the derivative of the velocity function at a time of 2. So if you take a second and use your good old quotient rule here to find the derivative of the runner B's velocity function, we will end up with, and you have to do some algebraic cleaning up, but when we do our good old low D high minus high D low over low low, we have 72 over 2t plus 3 quantity squared, and we wish to evaluate that particular derivative at t equals 2. And when we do that, we will get 72/49. You can leave it like that, or it's always a good idea to, on the AP exam, they'll require 3 decimal places. I always suggest going out to 4. But if you're going to do 3 decimal places, we have 1.469. And don't forget, this is an acceleration. My units are meters per second squared. So that's part B. Last but not least, we had part C. And in part C, they wanted us to find the total distance traveled by both runner A and runner B during that period of time. And this question actually harkens back to our jet tour of Calc back in September. So if you were to look at the graph of runner A's velocity and think about the meaning of a single 1x1 block of area comprised on that graph, a 1x1 block would be 1 second wide, and it would be 1 meters per second tall. And therefore, the area of a single one of these squares would represent 1 meter. So it's that accumulated distance that runner A is achieving over that particular period of time. So I need to integrate these functions in order to find that distance. So I need to integrate runner A's velocity function from 0 to 10. When I do that, that space is made up of a rectangle that has the dimension 7 by 10, and a triangle whose base is 3 and height is 10. So when I take those two areas and add them together, I will end up with an area of 85. And remember, that area is representing the distance covered by the runner over that period of time, so it would be 85 meters. Now, likewise for runner B, I need to integrate runner B's velocity over the interval from 0 to 10. If I were you, I would absolutely use this as an opportunity to utilize my graphing calculator. If you're working on one of our Classroom 84 pluses, you're going to select the math button, the most ridiculous button on a calculator, the math button. And then if you select 9, you'll see your integral. You can type in the integral you wish to evaluate along with the 2 limits of integration, and you will end up with 86.336. Of course, again, our units here are given in meters. I hope you found these solutions to be helpful. Keep asking questions, keep up the good work. I'm looking forward to meeting up with you guys again soon. Take care.